Hello, good morning everyone. My name is Nurul Padilla Anwar and my NPM is 2521531111036. Today, I would like to present an article titled An Overview of Problem Solving Studies in Physics Education, written by Ellie Pins and published in 2018 in Journal of Education and Learning. This article reviews many studies about how students learn to solve problems in physics and what teaching strategies are most effective. Next, background and purpose. In this slide, it says that problem solving is considered a central goal in physics education. This means that teaching physics is not only about delivering formulas, but about helping students think and solve problems logically. However, the article also explains that many students can memorize formula, but they struggle when they face new or unfamiliar problems. This happens because they do not fully understand the concept behind the formula. So, the purpose of this review is to analyze research conducted between 1980 and 2017, identify common findings, and determine which teaching strategies really help improve students' problem-solving skill. Next, concept and theoretical framework. Here the article defines a problem a situation that creates difficulty or requires reasoning to reach a goal. In other words, a problem is something that challenges students to think, not just calculate. Problem solving is described as about cognitive and metacognitive process. Cognitive refers to thinking, while metacognitive means being aware of and controlling our own thinking process. The article also presents a general model of problem solving. First, understanding the problem. Second, planning a solution. Third, executing the plan, and finally, evaluating the result. These steps help students solve problems in structured and systematic way. Next, research trends and focus areas. This review includes different types of research, such as qualitative, quantitative, and experimental studies. One major focus in difference between expert and novice problem solvers. Experts usually analyze the concept deeply before applying formulas, while novices often search for formula immediately. The research also highlights the importance of using multiple representation, like diagrams and graphs, to help students understand problems better. Another important focus is metacognition, meaning students need to reflect on how they think and solve problems. Next, major findings. The findings show clear difference between expert and novice. Expert focus on underlying concept and use systematic reasoning. On the hand, novice often rely on surface figures and formulas without fully understanding the concept. The article also finds that explicit instruction of problem-solving strategies significantly improve students' achievement. In addition, cooperative learning, multiple representation, and metacognitive training help increase students' motivation and confidence. Next, conclusion and application. In conclusion, problem solving is not just about applying formulas. It is a complex skill that requires conceptual understanding, strategic thinking, and self-reflection. The article suggests that teacher should explicitly teach problem-solving steps and encourage students to focus on concept rather than memorization. It also recommends that future research should explore metacognitive process more deeply and examine the long-term effect of strategy-based instruction. That it's all about the overview of problem-solving studies in physics education. Thank you for attention. Bye-bye.